Revit one. So how exactly to place the chillers? So in this one, I think you're familiar with this one. So if you want to load any command, any equipments, let's click on the mechanical equipment and load family. So in the load family, you can go back to the mechanical. So just let me know, air chillers are the water components or air components? For right now, we just learned chiller. What is the function of chiller? To just convert the temperature of the hot water to cold water. So obviously, all the connection should be pipe connection, right? So if it's a water side component, we have to click over there and you can find chillers, cooling tower, pumps, tanks, all the water related component placed in this library. So chillers, you can see all types of chillers are there. Okay, and same cooling towers right there. So what are the types of this cooling tower? You can see this is all about the load calculations. So designers have some load calculation according to the buildings. Let's say we have this much power of cooling tower required. So you can see the numbers, how exactly it changed. This is all about the powers. Okay, so we are going to just working on the project. So we have the proper submittals. I will explain you later. So accordingly, we will download the family or create the family of the cooling towers and chillers. Okay, so according to the function, like if you can just go back to here, we have the first system chillers. There is a cooling tower. AHU is the part of same thing like this. Okay, so inside the AHU, the systems, the functions, sorry, the fixtures, what we discussed, there is a fan, heating and cooling coils are there, filters are there. All these systems include in the AHU, and there is a box that's combined of sheet metal box. So AHU unit should be like this. We are not going to place all those single equipment. So we have a proper family of the AHU. Okay, but you will get the idea how exactly the AHU works. So again, it's a filter that we call louvers. Outside air strike through these louvers. There is a pre-filters that remove the unwanted gases and air particles from this one. There is a final filter. Okay. After that, you can see there is a cooling coils. Even the heating coils also there in the AHU, but they have not shown in this example. So cooling coil system over here. Did you see this gray pipes? This one. So this is coming from the chillers. Either if it's a cooling coil, so it means the cold water, normal water will say, coming from this chiller and connect with this one. And if this is a heating coils, it means they turned off the valve from the heating cooling coils and the hot water will flow. Getting my point? Any questions?
No, sir.
Okay. So once the once the water will strike through this cooling coil, air will come, and after this, this is the system connect with the multiple spaces of the room through the ductwork. So air will go like this way. There you go. Same example, but they have shown ducts also. Exhaust outside. Just look at this one. We have done every time this type of job in the HVAC, but before that, we are familiar how exactly the duct connected with the AHU, right? Because when you are going to model something in the Revit, so probably you will connect the AHU with the return or exhaust there, but you can at least understand what type of duct system required and from where we have to connect the supply and return. Got it? So exhaust, outdoor units, you can see how it works, filters, there is a specific filter over there also, cooling coils, and this is a return, and I believe this is the supply air. You can see more one example, filters, fan, supply air, Going back to the units, and again, it's HVAC, right? So HVAC, whatever the air will go inside the room, so there is a probability to recirculate that same air with the same CFM value and go back to the machine. So means, for example, in this room, there is a let's say 500 CFM air will come through this duct. Mhm. So almost we have to send back at least 400 CFM air through this duct and go back to the AHU. The same thing they have shown over here also. You can see.
Yes, sir.
Okay. And what is the, oh, sorry. So it's a 500 CFM. It means this is the calculation, the air, we can calculate the air in CFM. In US, basically, they have used the CFM value, imperial system, that's called cubic feet per minute. Okay. In Indian projects, we can use LPS, lucate per second. Okay. This is called cubic per, 1 second. Oh, sorry. So we can measure the air in this form. It's called lucate per second. Okay. So the orange color you can see over here, this is again the return air. So the return air will come back and connect with the the duct system, and again fresh air strike with this return and again come back. So the cycle will be going like this: one, two, and again three, and again one, two, three. Got it?
Yes, sir.
Okay. So come back to the project. Sorry, before we just start, or we can discuss about the whole project, just give you the single example, of one of the room. Let's say this one. If you can see this one, just can you tell me know what exactly this is?
Air terminal.
Mhm. This is also a terminal.
Yes, sir.
Yes, and this is called fan coil unit. The system what we discussed over here, same accordingly. You can see the whole system. It's a fan coil unit. So what is the system name? Is it a return or it's a supply? Relate with this document, the image, what exactly we have seen. From the machine, what system will come? Supply or return?
Yes.
What system? What duct system will come? Supply or return?
One is for return and one is for supply.
Supply? Is everyone okay with this system or no? Abhiram, Sandhya?
Sir, is FCU and AHU same?
Yep, everything should be same. I'm just talking about from AHU or this fan call unit. What system will come? This system. We just talk about this system and this system.
Ducted fan coil system.
Air systems always define in three form. I thought you done learned all these systems in the last session. That's why I described this one. So you know this thing, supply, return, exhaust, fresh. Okay. Now, if I'm just talking about this system with this one, or else let's say we'll make one room over here. I'll just give you the basic sketch of this one. There is a room, okay, and here is a roof. On the roof, let's say we have a bigger AHU. We have a two room here. The duct will come like this. Mhm. What is this type of air? Is it supply, return, exhaust? What?
So supply air.
Supply air, right? Everyone is okay with this, right? It's a supply air. So what is the return air will required and come back to this one. So we have to model a return duct also. That's probably, this is called, let's say, XCFM value. Return air always equal or less than CFM. So it means the return air will come like this, come back to here and connect with the machine again. That's called return air. So where outside air and exhaust air required. Keep in your mind always exhaust air always required either in the bathroom area, right, or kitchen area. In the bathroom, there is no requirement of the supply. Sometimes they can put the return diffuser also in the bathroom area, but always we require the exhaust air. There is no specific air requirement in the bathroom area, even in the kitchen area also. Okay, so exhaust done. Now, what is fresh? Sometimes, let's say if we have a residential building in the corridor, we are not accessible corridor every time. Mhm. So what they have done, we have a bigger corridor here. We have a specific classrooms or let's say units plans for whole building, all the AC units required over here. For the corridor, they have a put a one whole duct for the fresh air. Means the air will come outside. They can put a one fan over here and they can install diffuser. Just normal air requirement in the corridor. So for the specific case, they can install the fresh air also. Even you can see here also. I think, yeah, the outside air will required here. There is no specific duct system required. So what they have done inside the machine, the work will be go like cooling required due to this the cold water. There's just only the outside air entered through this machine. Okay, and whatever the air will come, the temperature should be let's say 10, 15, 20 degrees Celsius for this temperature. Now I'm jump back to again the project over here. If you can talk about this two system, this is called supply system because if you can, this is the machine, right? So we have a one outlet, two outlet. The same thing we have discussed over here. One outlet and two outlet. For FCU or AHU, the duct system always in two types, return and supply. Okay, so same here also, we have a return and we have a, sorry, we have a supply over here right now, and there is no return required for now. We'll show you exactly how returns will work. But for this project, everywhere you can see, we have another room here also. So whatever the supply will come, this is a supply, air will go like this and this. Okay, so I will create just a basic requirement of the HVAC system over here so that you will get the idea. Okay. Now, so first of all, I want to understand the systems of the duct. So when I click on the duct here, you can see duct, supply, return, exhaust. So what is missing here?
Fresh.
Fresh air. So always remember, if you want to create the system in Revit, okay, let's say we have a specific three system. Sometimes in the project, let's say low supply air, high pressure supply air. Low pressure supply, high pressure. Low pressure supply means required maybe for in the corridor area, in the room, high pressure supply air required. So this is called system type. We have to create the families. There you can see duct system will be there somewhere. Here you can see supply, right click, make a duplicate. Okay. Now, when I click on the duct, you can make a multiple systems. Got it? So let's make a basics system of the HVAC. So here is a wall. I'll just make a wall of 10 feet. So we have a place wall over here also. Let's place doors. Ceiling. There. Okay. Now, so we have we placed a ceiling. Let's start placing the ductwork. Before that, we have to place AHU. So I want to place the AHU on the bathroom area. So come back to this position again, and we have loaded a mechanical equipment. So we can just click over here and load family. So I want to place the FCU. So it should be under mechanical again, MEP. So now I'm talking about the air system, right? Because FCU, what we say, air terminals, everything included and placed in the air side components. So click over here, air conditioning, terminal units. There you go. See, ceiling ducted. Okay, you can see we have a multiple types of the fan coil units are there. We have a horizontal, we have a verticals also. So I'm going to place simple ceiling based ducted fan coil unit. I'm going to place over here CM. Mhm. Let's we have a specific C. This is what cubic feet per minute, and this is the total load of this equipment. why exactly the number will change? If we have a bigger space of the requirement for the AC, we can increase the whole unit size. And I guess you remember like how exactly we can rotate the equipments. Space, just click space and rotate. Got it? So I'm going to change and let's place 800 CFM. Any questions till now? Does everyone know how to load the families?
Yes, sir.
Okay, so I'll just place the equipment over here, and in the before we discuss the whole system, we just learned. So there are specific four connections we always seen over here. So what is that? Always duct HVAC system, even it's a in and it's out. What is this? This is a out system for the piping. Okay, if you can compare with this one, sorry, the one equipments, ductwork, piping, and electrical. So in the mechanical unit, whenever you saw this type of system, there is symbol you can see volt power. It means there is a power connection required. If you can see this type of snake type system, snake type pipe you can see here, this is called the drainage. Okay, and these two called the supply and return system for the mechanical pipe. So I'm going to install first, let's say ductwork. So ductwork for this one, if I just click over here, I'm going to connect with this duct easily, right? But we are going to understand how exactly this project work according to the field. So in the field, there is no specific straight duct required from the mechanical units. No, whatever the equipment you can see over here, there is no specific straight duct required. You see, there is a 12-inch duct, and how this duct will reduce over here. Have you seen this one, right? So what happened? Again, there is a theory. Once we install the machine either above the ceiling, there is a noise, noise basically happen inside the supply air system due to the fan vibration or something else over here. So we can use here is the flex connector. So the flex connector should be like this. The names what we discussed in this class, please guys just read on your notes. Okay, this is very important when you are going to start HVAC job, or let's say if you're sitting in the interview round. So all those small equipment names are very very important. You can't see these equipment names here also. So flex connector, that should be like something like this. I hope you can see my Google screen, right? Because I'm sharing my screen, so I don't know either if you can see or not. Can you see it? I'm just sharing duct connector
Yes, sir.
images. Okay, okay. So look at the one of the example. This is a fan coil units. This is a fan coil units. The black fabric you can see over here. This is a flex connector. It's nothing, just wrapping with the material of the fabric and connect with the fan coil. This is almost around 6 inch, okay, distance from this to this, and this is the connection with the ductwork. You can see whatever the duct required here, this duct and the opening of this fan coil is totally different. So whenever we start working on this one, okay, in the project, we always remember the first piece of the fitting is always flex duct connector. Everywhere you can see, it's the best example. And what's the function? To reduce the sound pollution, because there is a machine, so there is a lot of whistle sound create if we can directly connect with this one. And again, the connections, what exactly we have done over here with the help of screws. So probably if it's a vibrations happen, so there is a chances to remove the holes from this portion. So there is a fabric and they can easily connect it. And the fabric basically reduce the amount of the sound from this machine. Okay, so that's why this is called 6-inch flex connectors. Okay, in any units you can see something like this. Got it? So now in our project,